9-1 Exponents Multiply Notes. So we've got some new vocabulary to add. Whenever you're dealing with exponents, those are the little numbers that are up at the corner of our big numbers. And our big numbers in this case are called the bases. Now what an exponent actually means is repeated multiplication. So that number is telling you to take your base number and multiply it by itself 3 times. Okay? So that's all we're dealing with the exponents. Now today we're going to be given problems that look like this, like example number 1, and we are going to have to simplify them. Now these problems are considered simplified when they don't have repeating bases, which means you can't see the same letter written down more than once. And you also can't have more than one coefficient. We're talking about those big numbers that are in the front of the problems. So let's go ahead and break down example number 1. What's happening here? I've got x to the 3rd power, which means that I've got 3 x's all being multiplied together. And x to the 5th power means that I've got 5 x's all being multiplied together. So if I'm doing x to the 3rd power times x to the 5th power, well really what I'm doing is multiplying together 8 x's. So the simplified answer for this one is x to the 8th power. Okay, once that unfreezes, I'm going to point out something. It only has that letter written down once, so that's why this one is going to be considered simplified. So we add how many x's are being multiplied. Now for the next example, this one is numbers instead of letters because I want to prove to you that these two things are actually the same thing. So I'm going to show you what the answer is for example number 2 if I was going to use my calculator to do this. So I've got 2 squared and I'm multiplying that by 2 to the 3rd power. When I hit enter, I got 32 for my answer. Now here's my proof that this is the same thing. If I've got 2 squared, that means 2 times 2. Oh, let me let it unfreeze. Sorry about that. 2 to the 3rd power means 2 times 2 times 2. And if we're multiplying these two things together, that means we are multiplying 5 2's all together. So that's 2 to the 5th power. So my proof to you that this is the same thing as 2 to the 5th power, well, that equals 32. And if I do 2 to the 5th power, that also equals 32. So they are the same thing. So this was just a proof for you. All right, let's go ahead and take a look at example number 3, and we're going to break this down. Now, what you have to be careful about, because we've got more than one letter on this problem, exponents only repeat what they touch. So for example, I've got g squared. That squared only applies to the g. I've got h to the 3rd power. That only applies to the h. I've got h to the 4th power. That only applies to that h. So this one doesn't have a number. There's an imaginary 1 right here because we've only got one g value. So let's go ahead and break this up. This is a 2. I've got g to the 2nd power, so I've got g times g. Then I've got h to the 3rd power, so 1, 2, 3. And now let's multiply times the other one. So this is multiplied times 7. I've got a g. That g doesn't have an exponent, so that means there's an imaginary 1. There's only one of them there. And then I've got h to the 4th power, so 1, 2, 3, 4. Now you can put the dots between them so that you know that we're multiplying, but you don't have to put those dots if you don't want to. So now what we are going to do, we need to multiply the big numbers together just like we always would. So the 2 times the 7 ends up giving me 14. So I'm going to multiply, and that's how I end up with 14. Now I have the letter G, so I'm going to count up how many G's are being multiplied in this problem. I've got 2 right here and 1 right here, so that means g to the 3rd power. Now for my h's, I've got 3 here, and it looks like 4 here, so that gives me 7 total. So this is the simplified answer. I only have one coefficient, that's my big number out in the front. I can only see g written down once, and I can only see h written down once. Okay, so it is simplified. Now some of you might be realizing at this point that you could add the exponents, and that is what is actually happening on this. However, for half of the assignment, I am going to require you to expand your letters like this, so go ahead and get used to doing that. You do have to do it to get credit for this assignment. Okay. So example number 4 is another multiplying problem, and the way that you can know is because the parentheses are touching right there. There's nothing in between the parentheses, so it's just a multiplying problem. So that means I've got 8, I've got m to the 5th power, so 1, 2, 3, 4, 5. I've got n to the 4th power, 1, 2, 3, 4. This is being multiplied by a negative 3. I've got m to the 3rd power, so 1, 2, 3, and that n does not have an exponent, so that means that there's only one of them there. So when you put your answer together for this one, you need to multiply the big numbers. Okay, so the 8 times the negative 3 gives me a negative 24. And then we're going to add up how many letters we have. So I've got 1, 2, 3, 4, 5, 6, 7, 8 m's, so m to the 8th power. And for my n's, I've got 1, 2, 3, 4, and then a 5th one there at the end, so n to the 5th power. Example 5. Okay. Problem on example number 5. Whenever we get this one, for some reason, a lot of people want to take this 3 and they want to distribute it. They want to take that 3, letting it unfreeze, and multiply it times the 5 and times the 2. But that's not what's happening here. This is when you would distribute, when you've got more than one term inside of your parentheses, and terms are separated by plus or minus signs. So there's no plus or minus signs on here. That's why there's no distributing. All that we are doing is one giant multiplication problem. So I'm going to start off with the 3a squared. So I've got 3, and then a to the 3rd power means 1, 2, 3 a's. Okay. Then I've got a 5, so this is being multiplied times 5. A squared is a times a. That b doesn't have an exponent, so it's only there once. And then I've got my third set of parentheses. So I've got 2. That a does not have an exponent touching it, so that's just a to the 1st power. It's only one of them there. And then b to the 4th power, so 1, 2, 3, 4. So just like the other two problems that we did, when you've got those big numbers out in front, the first thing that you are going to do is multiply them all together. So we're doing 3 times 5 times 2, all in one big step, which ends up giving me 30. All right, so now I'm going to add up how many a's I have. I've got 1, 2, 3, 4, 5, 6, so a to the 6th power. And for my b's, I've got 1, 2, 3, 4, 5, so b to the 5th power. I only have one a written down and one b written down, and I only have one constant, so I'm finished. Now, like I was saying on one of those problems, what's actually happening here is that you are adding your exponents. So just to kind of show you, I've got a to the 3rd power, so 3 plus 2 gives me 5, plus one more right there gave me a to the 6th power. And for my b's, I've got 1 plus 4, which gives me b to the 5th power. So on the second half of this assignment, if you would like to use the rules, you can start using the rules. And I'm going to show you what that would look like on examples number 6 and 7. However, if you would prefer to keep expanding on all of your problems, that is fine by me, okay? But you do have to expand on problems 1 through 8 today. On 9 through 16, that's up to you. Okay, so we're going to practice using those exponent rules instead. And when you do this, I'm going to start by rewriting this problem so that I can actually see all of the exponents. So if some letter doesn't have one, give it an imaginary 1. I've got that negative 2. I've got an x, and since it doesn't have an exponent, I'm going to give it a 1. In the parentheses, I've got x to the 1st power, y to the 1st power, and z to the 1st power. I'm going to go ahead and close that. And over here, I've got 9. Then I've got x to the 1st power, because it doesn't have an exponent, and y to the 3rd. Okay. So when you're doing one of these giant multiplication problems, and this time I'm going to show you what it looks like if you don't expand, you still need to multiply the big numbers. A common mistake is when people start adding the exponents, they start adding the numbers in front too, the coefficients. But this is a multiplication problem, and big numbers behave the same way they always have. They're just going to be multiplied together to give us negative 18. Now from there, I'm going to count up how many x's I've got, how many exponents. I've got 1 plus 1 plus 1, so altogether I've got x to the third power. For my y value, I've got 1 here and 3 here, so 1 plus 3 gives me a positive 4. And for my z, I only have one z value, and you can put the 1, but it's really not necessary. A lot of times we don't put 1s, that's why they always end up kind of imaginary. So there's my answer for number 6. Last one. I'm going to rewrite example number 7 with exponents. So every time I don't have a letter doesn't have an exponent, I'm going to go ahead and add it in there. So I've got 3a, that a doesn't have an exponent, so put a 1. Then I've got b squared, close the parentheses. Okay, over here I've got 4a, I'm going to put an exponent of 1 because it doesn't have one. Then I have b to the third power and c squared. All right, so just like on all those other problems, you multiply the big numbers. So those two are going to multiply together to end up giving me 12. And then from there, you would add the exponents. So for my a exponents, 1 plus 1 gives me 2. For my b's, 2 plus 3 gives me 5. And my c, I only have one c value, it's c squared. And we're finished.